Alright guys, so today we're gonna talk about risk quantification biostats. So I know my videos are getting better in the sense that I'm making it on my computer, but for biostats I really like doing it on my notebook because this way I can have a sense of domination. I don't know how to say that, but guys, let's talk about this topic. It might be very confusing for some people, and I try what I always tried to do when I was studying back in school before medicine. I used to try to understand the logic behind those formulas and even to write them down, even if I don't memorize them. So what I will try to do is give you this vision or this mentality that you don't need to just memorize those formulas. You can understand them, and as you understand, it makes sense to you. So it's easier even for the memorization. So when we see a number, there is the numerator and the denominator. So the numerator in a relation, it makes your results grows, and this, the lower it is, it also make your result grows. So if we divide, for example, 10 divided by 2, we would have 5. But if we have 10 divided by 5, we would have 2. So the denominator will make the number lower. So in the case that you divide the denominator, you would also increase the numerator. This is why when we are dividing the denominator, we could actually multiply the 10 in the numerator. So we can just do this and increase the numerator because you're diminishing the denominator. So in odds ratio, the logic is if we have, for example, chronic back pain, this is actually the disease, or in some tables it can be the truth, and here the test, but in this case is the risk factor and the chronic back pain, the result. So out of in odds ratio, we start with the disease. So the disease is here. So these are all the patients that have the disease. And these are all the patients that don't have the disease. So in this case, we have 15 people that have the disease. And out of that 15 people, we have 10 that lift heavy objects and 5 that don't. And we have 10 people here that lift heavy objects and have chronic back pain. So if we divide this by this, we can actually have a sense that the more you lift heavy objects, the more you have chronic back pain, because most people that lift heavy objects have chronic back pain. So the more you lift, the more you have chronic back pain, and the more you increase the numerator. So we start with the disease. All that matters. And if we have a relationship that when you don't lift heavy objects, you don't have the pain, and it's clearly linked, because if you don't do that, you won't have. So this is a beautiful number that comes from this table. Yeah, you remember that the denominator will increase the numerator if we decrease the denominator. So as more people don't lift heavy objects, they don't have chronic back pain, it turns out that those 10 people will increase this number. So the logic behind this is I'm dividing the people that something that really cause by something that do not cause, and increasing the result as is do not cause. So this is a relationship of association. There is a strong association. And one of the things we see on test day, even for step 1 or 2, is when you see case control, you can memorize this because odds ratio, we can use this mnemonic case and control to remember that you starting with the disease. In this case, you can actually see the odds ratio. And for relative risk, it's also kind of measure of association, but you're starting with the risk factor. So in this case, we're looking like for the PPV. If we were looking for lab test values, but you see relative risk, you go this direction. So out of 10 people that lift heavy objects, 2 don't lift. So 10 out of 12 people that lift, and in this case 5 out of 15 people don't have. So as you increase in this direction, you also can think of this number will actually increases the numerator and increases the relationship. So there is also kind of association, but we're starting with risk factors. For absolute risk reduction, when we talk about absolute values, it's important to know you don't have a relationship. It's just the absolute. So let's say if I have 10 people that has this problem, and all of a sudden now I have 8 people that has this problem. So 2 people don't have this problem anymore. So what's the reduction? It's 10 minus 8. So we have 2. So our reduction is 2. We're not talking about percentage, because percentage is just a relationship that we can describe in different numbers. But if we take in consideration 100% is all, you can see the relationship. So even though we're talking about percentage here, what's important is our absolute reduction. So 10 without the prevention. If we have, let's say, a measure that prevents heart attack. So without the prevention, we have 10% of people, 10 people out 100 has a heart attack. And we add a prevention measure, let's say now we have 1%. So we reduced 9% because because we have 10 minus 1%, it's 9. Okay? In relative risk reduction, we're thinking about the total. So total is 10. So if we reduce 9 out of 10, so we got 90% reduction. So it's quite a lot in relationship to what we had. So there is no relationship between those numbers, because we're not taking in consideration that this is the total number. The total number in this case is 100. So this is why we lost 9%. But in this case, it's 90% reduction in relation to this number. So this is the total now. So this is why it's a relative in relation to what we had before. All right. So absolute risk reduction is something that we can use to see how many people we need to treat, because there is an inversion relationship here. So in 100 patients, how many would I save if I save 9, if I reduce 9%? So every 9, I will actually save 1. Or in 100 patients, every 9 I save 1, so I would have 100 divided by 9. And you can also do, because 100% is 1. So the idea here is every 9 you save 1. So this is why NNT is inverse to ARR. So what I want you to understand is there is a logic behind those formulas, and you can, if it's not so hard, if you have a good intuition, you can use it to support you in the memorization, or even if you get really used to it, you doing your exercise, you're paying attention, it can help you a lot. So attributable risk is AR is kind of confused because you think it's a relationship, but it's not. So let's say if we have exposition to smoke, and 10% of people that smoke develops lung cancer, and with no exposure, 1. So you see that you have a absolute increase in 9%, but relatively to the 10%, you actually increase 90%. So by this number, we can imagine that we now know the attribute at the number need to harm, because in 100%, every 9 we harm 1. So you see attributable risk, number need to harm. In attribute risk reduction, number need to treat. So you can see that this makes a lot of sense. And also mortality rate is a concept that is very easy to grasp. We're talking about mortality, so it might be something to deal with death. And we just need to set how many people is our 100%. So if let's say it's 10,000 is our 100%, we'll have a relationship between the death and the total people in that population. So it's the mortality rate. You see, there is a relationship, and this is 100%. It doesn't matter, it's always 100%. So you're dividing something by the other. This one is 100%. So it's the mortality rate. And the attack rate, the difference is because 100% your exposure, and out those 100% you have the people that gets ill. You can change this number down here, but all that matters is the relationship between them. So attack rate is ill over exposition. And the case fatality is a little bit different, but the same concept apply. So out of exposure, the death. So it's like mortality rate, but in this case, it's just common people, and this is exposure. So we talked about of a lot of information. It's what I would recommend is do your own resume. Do you a favor, do this resume. You have to be able to explain this concept to you, apply it sometimes, make it you make it that way that you don't even have to think about it. And before your test, like one day before your test, you write them down, get the idea. So when they come with let's say attributable risk, or even this can be very confusing. Number needed to treat, number needed to harm. If you need in the, let's say, your last resource, you can actually memorize them, and then the first thing you're gonna do in your test day is write down those formula. If you're not so confident that you have that with easy access in your mind, you can just do it. But I really recommend trying to understand a little bit so you can improve your confidence. And that's it, guy. I really hope that this help you through your preparation. And if you have any question, just comment. If you want to um, if you want to give me some, ask a particular team related to step 1 and 2, I'll be here to help. I can make a class on that theme. And that's it. So if you like this video, like to the video, subscribe to my channel, and share it with your friends.